And we are live. Welcome everyone to today's breakout talk. My name is Ricardo, and today we're going to talk about Kubernetes operators, how to test and evolve them, and some best practices. This is not the introduction to Kubernetes operators. We'll briefly mention what an operator is, but here's some resources if you want to check out afterwards. Before maybe going through the slides again. I am a cloud infrastructure engineer at Square. My main focuses in the past were on code pipelines design, infrastructure and cloud automation, and building Kubernetes-based solutions. First question is, what did I use Kubernetes operators for? And one of the things was to build some sort of vertical autoscaling or custom autoscaling based on custom metrics, whatever these metrics could be. And here you have a link also to the vertical pod autoscaler and what they are doing there, and a bit of an idea of what the problem was. Scheduling, this is based on, you have your custom metrics, you do your autoscaling, and you can also build a scheduler in Kubernetes and still use custom resources and operators to do custom deployment, for instance, on network regions with different constraints. Now, lately, I've been using it to build a self-service platform on top of Kafka, where our users can provision Kafka resources via our platform, and our platform is basically an operator and a set of custom resources. Today, brief introduction on operators, the operator SDK, and KubeBuilder. We are going to look into some of the best practices you can find in the internet, and I'm going to point out some that I believe are very important when writing good operator code. We are going to take a deep dive into custom resource definitions, how to version APIs, how to validate, and a bit of where and how to do defaulting and deletion. A bit of a brief mentioning on testing. Testing is very important, and operators are usually very complex things that evolve over time, and you tend to write them as automation scripts, and then they evolve into proper software. So testing and especially integration testing is something that we will cover today. And then I'll show you a bit how to monitor your custom resources, and we'll do a short live demo on how to use kubestate metrics to monitor your custom resources. So let's start with the intro. An operator is basically a process that watches the Kubernetes API for events on a limited set of resources, be them your custom resources, be them native deployments, and then it takes actions based on these events by retrieving the state from the cluster, from the API. You usually use your operators to, let's say, manage resources, either internal in the cluster or external. So you have maybe, in the Kafka example, you have Kafka users and Kafka topics, and what the operator does is basically creates these users and external services. Once an event is triggered as well, what happens is the operator reevaluates the states of the cluster by the API. It does not act on the change, but it acts on the actual state of the cluster, and then it does creation or update or delete of the various resources, external and internal. Why do we need operators? Custom resource definitions are arguably one of the things that make Kubernetes successful, and you can use and reuse Kubernetes features like scaling or scheduling, and still be able to extend it with your custom logic with a domain-specific language. And this is very interesting. So here we are looking at the custom resource. I'm hoping you're familiar with the difference between the definition and the custom resource. The definition is basically specifying, okay, what does this select mean? What does this endpoint mean? The description, what is in these? And here we have a service monitor that's a custom resource of the Prometheus operator. And the custom resource is what your users usually find. So they say, I want to monitor my service in Kubernetes. This is the selector that matches this service, and I want to monitor or to get the metrics from this port called web. Basically, what the operator does, it allows you to use a specific language to tell your users, okay, you want some resources, please write them in this YAML file, and I'll do everything that a normal or human operator would do to provision these resources. The framework that I've been using in the past and I recommend is the Operator SDK. The Operator SDK is built on top of KubeBuilder. It allows you to write operators in Go, Ansible, and Helm. Here you also have a nice picture of what the maturity or what your operators can do depending on the language you're using. Language with quotes. Most of the time you will end up when you really want to write an operator, you write it in Go. Um, why do you want to use a framework? It is obviously easy to deploy new custom resource definitions because KubeBuilder in the background builds all the boilerplate for you. It is easy to add new custom resources and also extend your APIs. It is already set up for testing, or at least a tiny bit, and you already have a structure that you can use, so you can basically speed up your process very fast. And then you also have other tools like the operator lifecycle manager. Best practices. So always take best practices with a huge pinch of salt. These are some they recommend. They found in the internet. Here, I'm just going to show you of the things that out of these and out of my experience are very relevant. The first one is your CRDs or your construct is your API. When you have multiple API versions of the same custom resource definition, it gets very hard for users to understand. The same thing as when you have multiple versions for your REST API. So make sure to evolve your APIs in a meaningful way, and we will discuss how to do this in the future. Here, I'll just give a brief example. You decide, okay, I have my first version, then I want to change something, and then I don't like it anymore, and now I have 3 versions, and your users basically have 10 resources with 3 different versions with minor changes, and they don't really understand what they should use. Perform validation as soon as possible. You have multiple tools, and we'll see them to perform validation on custom resources, and try to avoid unnecessary replication of code. You have admission webhooks, you have OpenAPI Victory, schema validation, and you should not be focusing on validation in your reconciliation. Most of the time, you should put the validation before that, and then do your business logic in your reconciliation. Strive for idempotency is absolutely important. The reconciliation, this idea of, okay, I monitor these resources. When something changes, I take some actions, is very, goes very, very well along idempotency. Because if you don't have idempotent function, then what happens is if an error occurs, then your operator might get stuck or resources might be created multiple times. Make sure also to be able to recover from any error, especially when deleting resources. This is particularly important because sometimes when you delete resources, you have multiple external resources. Something fails for network connectivity issues, and then you're stuck. And once your operator is stuck, if you configure the cluster correctly, then you won't be able to kubectl into the cluster and delete things manually or update the finalizers. You would need to basically update your logic and redeploy the operator. Build reconciliation. Reconciliation of resources takes usually quite a bit of time. You can also benchmark this. But what I want to say here is don't steal other people's resources. If something fails and it's not recoverable, then stop processing it. Here, there's an example of what the return codes or the return values of the reconciliation look like in the operator SDK framework, and you should really understand what it means to return with an error, without an error, or after to requeue resources for reconciliation after a specific amount of time, because these affects other people's processing. So you might have other resources that are stuck just because you are retrying an operation that is failing. Your users should also be able to debug custom resource configuration problems on their own. This means that you really want to be informative in your custom resources or by events, and we'll see how to do this. So, custom resource definitions. Here's an example. As we've seen, this is a custom resource definition for service monitor in the Prometheus operator. And this basically tells, okay, I have a Kubernetes service. I want to monitor a port in this service that's exposing some Prometheus metrics. Make sure that your custom resource, I use the words custom resources and custom resource definitions interchangeably, but the main idea is custom resource is whatever you define that your user uses. So in this case, your customer resource should really be considered as a state machine. You create it, you validate your resource, and there are different tools: admission webhooks, OpenAPI with 3 schema validation, mutating webhooks. And then once it's initialized, you go into a processing phase. That's where your operator comes in place. And here you basically have 3 exit states. Either you fail, and for some reason you want to retry the reconciliation, you manage to sync the customer resource, or, and this is my argument, you really want to get into an unrecoverable failed state, so that your operator knows that that state is not recoverable, and to go out of that state, you need to do either some manual things, like adding an annotation on the resource, or going through the validation webhook. So multiple tools to do the same thing, but strive to put validation and using these tools at the OpenAPI with 3 schema level, and then at the admission webhook when possible. Have clear error states. This is very important because then that's what the users will see. And make sure that you are able, make sure that your users know how to delete resources in a way that doesn't require any input from your side. Make sure that your code is also separated in these 3 main categories of, create, update, and delete. This is what your operator will usually do: create resources, update or react to create events, update event, and deletion. And these are usually fairly different logic paths. And sometimes you can reuse some logic between creation and update, especially if you're managing external resources and you're doing these via a put endpoint or like a get plus plus. The idea is really try to strive for idempotency here and make sure that you don't get stuck in your state machine somewhere. One cool feature that you should use, in my opinion, is conditions. Conditions are a standard way in Kubernetes to mark information that is not easily recoverable from let's say, the cluster for your user. And this is the same thing you would see for your pod. So if your pod is ready, then maybe your custom resource would also be ready or not. And this is very informative for the users. Here, a condition is of type ready. You see that the status is true, false, or undefined, depending on the C. You can also have, for instance, an initialized condition. And then you can give a meaningful reason that basically for you also to know what reason got into a fail state, for instance. And this can also be used in your logic. And then give a meaningful message to your users. Condition really give you a single place where the user goes to figure out what's wrong or right with their custom resources. You can obviously extend this with metrics, and there's also an alternative that's recommended by many that's using events, and we'll see it in a bit. Try to avoid using imperative commands, and I really recommend to use webhooks when you have imperative commands, especially with GitOps and continuous deployment, because it's very hard. Like, you can do imperative commands by adding an annotation, but then how do you know that you already processed that? You don't really want the database behind your operator most of the time. So having, let's say, policy with imperative commands is very hard. Use annotations, that works, but use it sparingly. Remember that this is like the whole point of having custom resources is to have a declarative interface. So you really don't want to have as much imperative commands in there as possible. Do validation symplectic at the OpenAPI with 3 schema. So you can say this is basically what it does. So we have this type deletion policy and some Q builder annotation, and then this is a section of the custom resource definition that's generated from this annotation. And you see that here we're saying, okay, this deletion policy can only have 2 values: delete everything in this DNU. And if you want to do other sorts of validation, then use admission webhooks, or if you are on Kubernetes version 1.25 or higher, then you can use this amazing feature called common expression language that basically allows you to do more validation in the CRD, basically, without having to have an admission webhook. And my argument is webhooks are very hard to manage, and it's another piece of complexity you add on top of your operator. So if you really don't need them, you can use these features to do validation, and then please do. And of course, the common expression language also works with QBuilder. Some people recommend that you do semantic validation at both the initial webhook and in the operator logic, and you do it basically twice. It can make sense, but my argument is use conditions instead, have a proper state machine, and before it gets into the initial webhook, it's not admitted, and the operator will not process this resource. Once it goes to the initial webhook, then you can set it as initialized, admitted, and then your operator will process these resources with this particular condition. Deletion is very important as well. You use finalizers. When you create a custom resource, you add this basic tag saying you cannot delete this resource until my operator processes it. And here it's very important to be able to recover transient failures. This basically means that whenever, and here we have, I think, an example, if you have a reconciliation loop where you're deleting external resources and one of them succeeds, so we delete resource A and the resource B deletion fails because of some network error, then what you really want to do is not do delete A, delete B, but try delete H or delete if A exists. So have this pattern and make sure that you have idempotency, especially at the deletion, and be able to finalize your deletion even if something goes wrong, so long as it basically matches your business logic. Because otherwise, you get stuck in the deletion process. You basically busy up the operator trying to delete the same thing and failing over and over again. And this is both a problem for availability for other users, but also it's very hard to recover without changing the operator logic or going directly in the cluster and removing the finalizer from the resource. Hero ending is a very important thing as well, because that's how your users know where the problems are on your CRs. You can use events. Events are a very nice thing that you can also see in ROCD and give you some understanding of the immediate, say, status of your custom resources and other resources. The main problem with events is that they're not persisted by default, so you can of course persist them and maybe show them in Grafana or something. But I really say, and here there's also a very good blog post that argues how you can use events to basically give errors, meaningful errors to your users. My recommendation is, yes, you can use events, but you want to have a way that is persistent so that if today your user creates something that is not working or there's an error, then in 3 weeks you have some status and they can check it, and you have some persistency basically, and you can do this with conditions within the CR without having to add any other infrastructure for your events. API versions is also something very important. Know that the difference between served and storage versions. So you can have multiple APIs that are served, but there's only one storage version in the etcd. And you can hack it, but the idea is you have one storage version, that's the latest usually, and then you have other served versions, like the previous ones, that your users can still define, but in the background, you're only processing the latest version. And what this means is that there is some type of conversion from V1 alpha 1 to V1 alpha 3 and V1 alpha 2 to V1 alpha 3. This is usually done via webhooks. If you really need it, you can use mutating webhooks, but you can also, as we see in the last point here, dropping and adding fields is a very inexpensive operation. Renaming fields or having some business logic that moves from one field to another, some parameters, requires probably to create a mutating webhook. As mentioned, you can serve multiple versions, but since there's only one storage version, you really want to encourage your users to just always, when you create resources, just create them in V1 alpha 3 so that we could, in the future, easily drop the old ones. Use, as mentioned, conversion webhooks sparingly because it's more logic and it adds complexity to your system. Testing, some recommendations for testing. Try to move code to libraries that can be tested outside your operator. It's a piece of software. The reconciliation loop does some integration with the Kubernetes API, but you can also unit test that and really unit test pretty much everything and add integration tests to your external services when needed. Make sure that your tests are debuggable. This is usually very hard if you start from like the reconciliation loop, because it's very hard to mock things. And you really want to make sure that you have your unit tests, you can debug them, and you can test your business logic. And just in the main reconciliation loop, you just have the few ifs that allow you to decide whether to create, delete, or update. As mentioned, make sure you can mock things, you can test your functions, and you have some very good examples. I recommend you to look at the Elastic operator, because it has very neat code, and I think it's very interesting to see how they structure the testing, and it also resonates a bit with what we're saying here today and the tools we're using. If possible, don't rely on an existing cluster for testing. So you tend to have like your K3D or Minikube cluster locally, and then you deploy your custom resources and do your testing, and sometimes you do it manually. But also for integration tests, you can really, there's a framework that we will see that allows you to spin up a control plane without having a cluster. And then if you really want to test against the live cluster, you can just tune it in. So some recommendations for API mocking. There's plenty of tools. Mockery is one of them. Basically, it allows you, given a Go interface, it auto-generates a mock implementation of the interface. You've seen it in other languages, of course. This is very convenient to test where you to mock external services. So you just wrap your external service and basically go go through that. You just create your interface, do your implementation below it, and then use a tool like Mockery to generate the mocks for you to test. And if you really want to do some like low-level testing of your services and maybe some payload parsing or so, you can also use tools like HTTP mock that actually mocks the endpoints if you really need, because it's not very maintainable. And I think it's always easier if you just do, let's say, test your logic and not test the external services. To test external services, just have one or two integration tests. And my argument is really using integration tests to test the external services and really build your code so it is testable in a unit test way without having a live cluster. It's very common and very nice to use domain-specific language also for your tests, because usually these reconciliation loops do a lot of things and your test might get fairly long. And here it's very nice to say, okay, when the cluster restarts, the node should restart and should fail to begin restarting, for instance. And this gives also other developers that join your team a very nice way to basically onboard on this fairly complex piece of logic. mtest is a tool to basically spin up a control plane that you can use for integration testing. And you can, as you can see here with the environment variable, we are just saying, okay, if you want really, then you can use an existing cluster. So you basically write your integration tests that run against testdem, but at any point in time, you can switch in your cluster and run the same test against your live cluster, because maybe you can do some live debugging when the test fails. So very interesting tools. Links in the slides. We will share the slides afterwards in the various channels, so on the meetup post and in YouTube. Monitoring. This is probably the last big topic of today. How do you monitor your custom resources? And here we found that using kubestate metrics allows you to monitor custom resources, and it is very easy to add and extend metrics, so that you get basically some metrics in Prometheus by using a very well-known and tested tool, and just meant for your custom resources. So this is also a very good way to provide a picture of the resources for your users. If you're an Argo CD and you have multiple applications and your users have to monitor resources in 20 namespaces and they don't have direct access to the cluster, then it's very hard. And usually they have to click on the various resources to check the status, and providing metrics and a Grafana dashboard allows them to do this in a way easier way. So the main problem with kubestate metrics at the moment is that you require to reload the configuration, to restart the pod. to basically reload these metrics configurations. There are tools that allow you to do that automatically, such as Reloader, and you can also see that they are working to improve this and have auto-reloading of configurations. This is not a big problem. Why? Because we are using our kubestate metrics just for our custom resources. So if you already have your kubestate metrics in your cluster, don't use that one to monitor your custom resources. Spin up a new instance that just does that, so that you can reload it as often as you can, and you don't impact other people and the global metrics. So here, quick demo. We're gonna create a mini kube cluster. We are gonna disable the metric server. We are going to create a namespace and use the Kubernetes project to deploy Prometheus and Grafana. And then we are going to use a gist that I upload to GitHub that you can, it's basically a setup that I'm showing you on how to get your first custom resource, your first metric for your custom resource in Grafana. And then we're just gonna see how it goes. So now I'll quickly switch to the other window. This one. Yes, so I already started my cluster. Seems like it worked. And then I am going to disable the metrics server, as we said. Why? I mean, it's not really required, but we just want to make sure that we are the only ones that are generating metrics. We create this namespace monitoring, and then we use the Helm chart to install Kubernetes. Hopefully this doesn't take too long, and amazing. So it worked. Here we are gonna have a look at the gist in a bit, but first let's go through the old failed byte body because we are doing something bad, probably. Okay, this was fine. Let's do the usual manual debugging. kubectl apply -f minus, be better. And then let's get a URL to basically check our metrics. This might take a while. In the meantime, I'll show you what we have here. We have our Kubernetes deploy. Kubernetes is a nice project that allows you to deploy the whole Prometheus plus Alert Manager plus Grafana dashboard all in one. And here we're seeing that things are still spinning up. And what we are deploying is these kubestate metrics. And here, if we have a look at this one, -o YAML, here we can see that in this pod, we have basically we are basically saying we want to monitor our custom resources only. So our instance of kubestate metrics only monitors custom resources. And then here is basically a specification that we'll see GitHub because this is a bit complex to read. And here is basically monitoring the service monitors. So what we did is if we do service monitor -a, that's the custom resource that we see before, we also are basically using a service monitor to monitor service monitors. That's what we're doing here. So let's go to the link, and I'll do once more a hot swap to the, we need the link here to the browser. Here, tuck. So let's see, select window, and I think, wait a second, this one, yes. So this is our Prometheus instance, and here, if we go custom, or it's maybe custom with the custom as with this one, we basically have our, let's say, this here, execute. We have our first, let's say, custom metric for our service monitors. And here, these are things you can put in Grafana that your users can see, so they have a single point where they have information about what of your custom resources are in a ready state or not. Let's maybe have a quick look, since I think is relevant to the gist that you can test, so that you never apply random things from the internet. Uh, but this is very simple. We have, and I'll zoom in. We create a namespace, we create service account, cluster role, and cluster role binding. This is all required for our kubestate metrics. And then we deploy the default kubestate metrics and specify these. So this can also be in a config map. It's easier to have it here, but you can just put it in a config map, use customize, and do the reloading automatically with customize. Here, we're just saying, please monitor, look for service monitors, create some labels based on the name and the namespace of these service monitors, and then just count them with the code. That's it. And we are also getting some labels from the annotations. And here you can really do a lot of things and monitor different resources and even different versions of your resources with the methods you need. That's it for this demo. So let's switch back to the presentation. Screen share window here. And we go off the screen again, maybe. Yes. Good. Delete, I'll do it afterwards. And this was it. We were very fast through it. So we will get some questions now. And hopefully you will like this introduction. There was a very nice video from yesterday from the CNCF YouTube channel that I will also link somewhere for you, that also states why your operator should probably be a Helm chart. Take a look at that one as well. In general, my also 2 cents on that is write operators when you really need them, add complexity to your operators, such as admission webhooks or mutating webhooks when you need it. And if you are installing things like they were arguing in that video, maybe you can also just use a Helm chart. This is it. Let's see if we have any questions. Getting it. No questions so far. Then thank you. Thank you for your time. Feel free to anyways reach out or post questions in the chat afterwards, and we will definitely make sure to answer them. Thank you.